Hi, I'm Jerry Ellsworth. I usually don't worry myself about safety, as you can see in some of my other videos, but when it comes to the laser cutter, you've got to be careful. Some of the materials that you may try to cut can emit chlorine gas, cyanide, or maybe even worse. Besides being health hazards, they may also damage your laser cutter, and we wouldn't want that. What I'm presenting here is a method to build a chamber to contain these gases and a way to pump them off and neutralize them or pump them into your neighbor's yard. We're going to take advantage of some properties of silicon wafers. You can find these wafers on eBay. Be sure to find ones that are polished and don't have any circuitry already on them. CO2 laser cutters operate in the infrared range. Silicon can pass infrared. Although we can't see through it, IR will go directly through. That's what I'm demonstrating using this laser pointer that doesn't have an IR filter in it. Okay, we're going to need some fittings to get the gas out of our chamber, a window so we can see what's going on in the chamber, a cookie tin that's deep enough for your workpiece but not too tall that it won't fit under your laser cutter, some tools like a drill, some silicone to stick down the wafer, and some cutters to open a hole for the wafer and the window. Okay, I'm going to speed this up a bit. I traced out where the wafer should go, and I'm going to cut just inside this line because I traced on the outside of the wafer. I just drilled a starting hole. Now I'm using some right-handed tin snips to go around, cutting a hole for the window, which is just a piece of plexi. Being sure to leave enough lip there where I can put some silicone down and stick the wafer and it won't fall through. I'm using silicone because the wafer is very fragile, and if the lid is bent at any point, the silicone may give a little bit of flexibility and save the wafer. I'm not showing it here, but on the back side I siliconed it also, and siliconed the gap between the wafer and the window. Okay, I put the fitting in the side of the tin. That way I can pull the gas out. Here we're setting a piece up. I'm using the measuring tool to get the focus correct before I put the lid on. So I had to build up, stack some stuff like a roll of tape to get my workpiece up high enough. Silicon isn't 100% transparent to IR, so if you do focus the beam directly on the surface, it will etch the surface a bit. So it has to be out of the focal plane. So you want to have the wafer as close as you can to your lens. Right, so I didn't have the pump ready to pump the gas out, but I hooked it up to my vent system that I already have and ran it up to the fitting. And there's the artwork. We're going to transfer through the wafer and onto the workpiece. One could imagine many other configurations of using a silicon window. I look forward to also adding a second fitting so I can purge the air and pass inert gases through, or even reactive gases to do other experiments. And let's take a look and see how it turned out. Perfect. And thanks for watching.